Let us develop a basic understanding on jute drawing. Firstly, let us understand the need of drawing for jute slivers. Thick carded sliver needs to be sufficiently thinned down before converting it to yarn by spinning. Moreover, for spinning a yarn of acceptable quality, this thin sliver needs to be fairly uniform and demands sufficient parallel arrangement of fibers in the sliver. Such a thin sliver is produced from thick finisher card sliver by using several drawing operations. Each drawing operation employs basically two sets of rollers: slow moving retaining rollers and fast moving drawing rollers, through which the slivers are passed. By this process called drafting, the input sliver count, say C in, is converted to an output sliver of lower count, say C out, which is simply equal to C in divided by the amount of draft, the ratio between the surface speeds of retaining and drawing rollers. By the process of drafting, the fibers also become more parallel. Let us now study the drafting process for a jute sliver. Any jute sliver has few fibers of long lengths and large amount of shorter fibers. During drafting of such a sliver, it is found that when longer fibers emerge from the drawing rollers at a faster speed, they drag out from the drafting zone a lot of shorter fibers along with them, mainly due to interfiber friction. For this, a thick place is formed in the sliver emerging from the drawing rollers. Due to such undesirable movement of short fibers, there happens a shortage of fibers in the drafting zone, causing the formation of a thin place following the thick place in the delivered sliver. This is known as drafting wave, indicating alternate formation of thick and thin places in the drafted sliver. Thus, any drafting process with slivers having fibers of variable lengths induce an irregularity in the drafted sliver. In the jute drawing machines, there are moving gill pins which are meant to offer some resistance to the unwanted dragging of shorter fibers by longer fibers, and thereby the chance of formation of more amount of thick and thin places gets reduced, and thereby the irregularity in drawn sliver gets reduced. In the jute drawing machines, there is also provision of doubling of slivers, by which more than one sliver, say 3 or 4, are combined to form a single output sliver. By doubling process, the irregularity of the output sliver gets reduced due to random chance of overlapping of a thick place of one input sliver onto a thin place of the adjoining input sliver. The objectives of jute drawing are set as A. To reduce the sliver count, that is linear density, in steps by the process of drafting. B. To parallelize the fibers in sliver by the process of drafting. C. To improve progressively the uniformity of sliver by the process of doubling. For producing majority of jute yarns, three jute drawing operations are usually carried out. First drawing, followed by second drawing, and finally finisher drawing. For producing very good quality jute yarns like sail yarn, four drawing operations are preferred for much improvement of sliver irregularity before spinning. But for producing inferior quality jute yarns like sacking weft, sliver irregularity is not much important, and hence true drawing operations, first and finisher drawing, are found sufficient. Nowadays, we are observing that some mills are using three passages of drawings for preparation of sacking weft. Let us understand the thinning down process as executed through three drawing operations for converting a very thick card sliver to a very thin drawn sliver, which can be conveniently converted to a yarn by the spinning machine. Usually, the first drawing machine executes a draft between 3.7 and 4.5 and doubling of 2. The second drawing machine executes a draft between 5.5 and 6.5 and doubling of 3. And finally, the third drawing machine executes a draft between 8.5 and 9.5 and doubling of 2. Please note how the average number of fibers per cross section N bar is going down from the finisher card slivers to the finisher drawing slivers after several draftings and doublings, and finally in the yarn delivered by the spinning machine using a draft, say 16. At first, we will study the fast drawing operation. This is a screw gill type fast drawing machine. Let us now understand the drawing process as executed by this type of fast drawing machine. This is a schematic diagram of a jute drawing machine. The feed slivers are drawn through a pair of retaining rollers and a self-weighted jockey roller placed on them. Then the slivers are drawn forward by the fast-moving drawing roller and drawing pressing roller, and thereby got drafted in the drafting zone with forward-moving several rows of gill pins. Thereafter, the slivers are doubled on the doubling plate and drawn by a pair of fluted delivery rollers. Let us now observe delivery of a creamed sliver into a can. The slivers are crimped within the cream box with the help of a self-weighted lever. This is krill, a platform for placement of several finisher card rolls at the feet and unwinding them for continuous feeding. Now we are observing that the finisher card rolls of different sizes have been kept on the creel. This is the right method for card roll feed, what is called staggered feeding. The slivers are passing through the drafting zone, having moving gill pins embedding the slivers. It is seen that some portion of the slivers are overflowing, that is, passing over the gill pins, which is totally undesirable, since these sliver portions are being drafted without the controlling action of the gill pins and thereby will cause increased sliver irregularity. We are observing how the gill pins are moved by the screws. At the front side, the gill pins are dropped from the upper screws to the lower screws by a proper cam movement. Here at the back side, we are observing how the gill pins are lifted from the lower screws to the upper screws again by the help of a can. We are observing the doubling plate by which 2:1 doubling is executed. The slivers are being crimped and the crimped slivers are collected in the cans. Such crimping is executed to improve the cohesion within the sliver so that sliver does not break easily during withdrawal from the can or passage at the feed of the next drawing stage. The tramping action is shown here, by which several layers of the delivered slivers are made compact within the cans so that a large amount of drawn slivers can be stored in a single can. The mechanism behind the up and down movement of the tramp is shown here. The positioning of the tramp head with respect to the can is shown here to indicate that the curvature of the tramp head matches very well with the inner curvature of the can. This matching is necessary to ensure proper compression of the slivers in layers within the can and also to avoid any entanglement between the sliver layers. We are observing the collection of drawn slivers in the cans. The cans are moving in clockwise direction for some time and again moving in the reverse direction for some time. Such movement of the can helps to prevent entanglement between the compressed layers of the crimped sliver so that the sliver can easily be withdrawn from the can as required at the feed of the next stage. Here we are observing the movement of the coiler plates, which in turn rotates the can once forward and then again in a reverse direction. Here the rotational pattern of the mangle wheel is shown. This mangle wheel actually gives the forward and reverse movement of the coiler plates through a pair of bevel wheels followed by pinions. Here, wrong doffing process is being shown. Here, the correct doffing process is being shown. Here, the defective drawing pressing roller with cuts is shown. This needs to be replaced at the earliest to ensure the regularity in the delivered sliver. This is a push-bar type fast drying machine. We are observing the feed of the card slivers now the movement of the gill pins in the drafting zone, and now the delivery of drawn slivers after doubling of 2:1. We are observing the design of the gill pins in the push bar drawing machine. Now we will see the operation of screw gill type second drawing machine. We are observing that the cans with different amount of slivers at the feed. This is again a staggered feeding. We are observing how the stop motion works in case of a breakage of a feed sliver. We are observing how the slivers are joined after a break. This is the drafting zone. The proper embedment of slivers within the gill pins or gilling is shown here. A doubling of 4:1 is shown here. A doubling of 3:1 is shown here. Wrong use of doubling plate is shown here. We are observing the sliver delivery from a second drawing machine. Here we are observing that the crimping weight is missing, which is very much undesirable, since for this the appropriate crimping of the output sliver cannot be executed, which may cause operational problem in feed of the next drawing stage. Now we will see the operation of screw gill type finisher drawing machine. We are now seeing at the creel side of a finisher drawing machine. It is seen that the sliver stop motion has not worked. Now the sliver stop motion has worked. Now we are noticing a correct splicing of sliver. We are noticing a wrong splicing of sliver. We are observing a screw gill type second drawing machine. 4 persons called pickers are seen engaged in picking and cleaning operations. The machine is seen